Okay, let's do the next one.
Next one. I'm flying, so
yeah, you can drive.
I'll fly and you talk.
Fly.
I need a rest.
Yeah, my turn.
I talked for like an hour. That's bad.
Yeah, I'll try to be quicker. So, pattern matching. How many people are familiar with pattern matching here? Because I think, I want to zip through this a little bit. Let me ask you this. How many people are unfamiliar with pattern matching? If there's not very many. Okay, so I'm going to zip. Well, let's just do a few slides, and then we'll skip. I think it'd be better to move on to partial functions.
We can probably skip a bunch of the early stuff and just talk about some of the advanced concepts in this one, then, can't we? So,
well, how should we do this? There's almost everyone.
I think probably it's worth mentioning bindings, because not everybody remembers bindings or knows about those. Very quickly, bunch of case classes. We're putting together a expression simplifier, which, given these expressions, these case classes, it's able to look for things that are simpler, like x plus x can always be replaced by 2 times x. And minus x is just x. Things like that. So simplify the expression.
Sorry.
What's up?
Nothing. Never mind.
That was very hand-wavy glossy,
yes,
wasn't
anyway,
it? Yeah.
Now let's go on to the pattern match actually.
Okay,
itself. So,
pattern matching.
Okay, so here is an example of a pattern match. And the nice thing, the one thing I think about it is it's kind of like expressions inside out. So in an expression, when you to evaluate an expression, you put in you fill in a bunch of holes. All the variables are holes, right? And then you evaluate it, and out pops one result, right? Whereas a pattern match, you put in one thing, and it could have unevaluates it, and out pops a bunch of things possibly. So,
sorry, I was.
So in this case, for example, simplify top, I'm passing in expr. And let's say actually only one thing's going to pop out of here.
If it's minus.
Yeah, if it's a minus e, minus anything, that will match, and out will pop what e is, right?
Yep.
And so you can have many things being popped out, and then they're available on the right-hand side. So,
let's move on. Wildcard patterns, if you haven't used them, quite useful. Basically, pattern matching, you've got constants. Anything you fill in, it will search for. Anything you don't fill in, it will give you back. So here's an example of saying binary operations that start with a plus.
Right. And then case underscore matches anything.
Yeah.
So that's the underscore is the wildcard, matches anything. So constant patterns are basically case 5. That's like switch has case 5 in Java, but you can use any constant or singleton object in a constant pattern in Scala. Let's go to the next one. Variable patterns, like the last thing, something else, matches anything, but it is available on the right-hand side. So
you give it a name.
Just give
case underscore matches anything. Case
doesn't
X
have a name.
Matches anything, but it gives it to you with that name.
Yep.
That's the difference.
And then if something else started with a lowercase letter, that's why it was a constant pattern, not a constant pattern, I'm sorry, a variable pattern. It matches anything, and then that's available on the right-hand side. If that starts with a capital letter, that's interpreted as actually a constant. So pi, because it's a capital P, it's not going to match anything, and then on the right-hand side, that whatever it matched is named pi. It actually is going to match the value of this constant pi, and the difference is whether it's a capital letter or a lowercase letter.
And if pi is not defined, you'll get a compile error at this point.
Right. So constructor patterns is really just like when you make a case class, for example. You don't have to have a case class to get this, but the idea is it looks very. That actually looks like an expression. If E is, if I could copy and paste that. If E was defined, I would get it would pop. I would evaluate an expression, and I'd get a binop object. So it actually, the way you construct a binop object looks exactly the same as the way you deconstruct it.
Okay.
So that's concept.
Sequence patterns.
So sequences you can actually do a few things with. Like up here, this first list 0 underscore underscore is just using the wildcard pattern.
Yeah.
It's only going to match a list of length 3.
That begins with
because
0.
I've got 3 elements there. I only care about that the first one is 0, and that there has to be 3. If you don't care how long it is, you can just put _*. That means in as many others, as many elements that you want in the sequence, as long as it starts with 0. Let's go to the next one. You can also, using lists, you can
use the cons.
Style. And this way, rest can be nil. It can be the empty list. So that first line there, A cons, B cons, C cons, rest, will match lists of length 3 or greater. Okay, so that's that.
Tuples.
You can match tuples. They just look like creating tuples. Again, it's kind of like constructor patterns. Case ABC is going to match a tuple of length 3. Well, it's actually going to match a tuple 3. It has to be a tuple 3.
It's going to be a tuple 3, yeah.
And
anything else will just go through. Yeah.
And then
types. This is the, I'm sure you guys have seen this, but this is the idiomatic way of narrowing a type. So this is like saying is instance of and then as instance of casting. Instead of doing that, you just say in the case where this thing is a string, and then you use it as a string on the right-hand side of the arrow.
So yeah, that's easier. The idiomatic way to do instance of as instance of. And one thing that here you'll see map __ is because of type erasure. It doesn't actually know at runtime what those underscores, what those type parameters are. You can put type parameters in there if you know you're really going to have a map of string to int. You can put it in there, and the compiler will warn you that, hey, by the way, erasure can't ensure this is true. So it will just match any map. And if it is true, then you can actually use it on the right-hand side. You can actually use it as a map of those key and value types. So it will trust you.
Oh yeah, that's just saying this is the poor version of type check and cast, and then the
one of the reasons it's a little verbose is to discourage it, and the encouraged way to do that is with a type pattern.
Did you mention that if you do fill in the types, it means something different? So if you say case M map of int to int, okay, instead of map _ to _, Scala is going to take this as you knowing that these things are both ints. Okay, it's going to believe you, not the other way around. It's not going to it's going to match any map, but it's going to say, oh, this must be a map of int to int because my user says so. And,
well, it does warn you.
It does warn you.
Yeah. And you say yes, I'm sure, and it'll let you do it.
Yeah, so that's a convenience, but it's a potentially dangerous one because you can end up with a class cast exception if you try and use it as an int and it's not really one.
Yeah.
So then there's
so
binding.
This is one of the things I want to see. This little @ sign here. So sometimes a pattern will, let's see how. Sometimes, a lot of times when you want a variable, you can just put a little name for that if you want something to pop out. But sometimes the thing you really want is more complicated than that. So an example is this unop. For absolute value. If you take the absolute value of the absolute value of x, then you can reduce that and simplify it by just saying absolute value of x. You can get rid of one of them. Right?
You can't get rid of both.
So what I could do in my pattern is say unop apps, comma, unop apps, comma, x, and then on the right-hand side of the rocket, unop x. Apps x. I can create a new unop with absolute value of x. But I already have one on the inside there that I need to have in my pattern match. So what I can do instead is say, I'll actually bind the inner unary operator object with the name E. That's what I do with that E @ something, means that when this matches, if it matches, then on the right-hand side of the rocket, E is that something. And so that saves me the trouble of creating a new, well, it saves me the performance of creating a new object when I already have one.
You use this a lot with XML and JSON processing and things like that, where you say, what I'm actually looking for is a book with, but instead of just getting the contents inside the book, I actually want the book object returned to me. So I'm pattern matching the fact that it's a book, but I actually still want it wrapped in book when I get it back. So I bind to book with some kind of contents in it, and that's the variable that I get back rather than the contents.
Little b, little k, @ big B, ook, blah, blah, blah.
Yeah.
Yep. Okay, let's move on. And then a guard is, where's an example? If
the guard is at the bottom there, if x equals y.
Yeah. like fourth line from the bottom where it says if x equals y. This one is if you want to say e plus e, I want to change that to e times 2 for some reason.
Well, x could be quite deep and need a lot of calculation, so you don't want to do it twice. You just do 2 times whatever that value is. So it's
that's a good reason. So what I can't say is x comma x, like I try in this top one here, plus bin op plus x comma x, because I can only use each variable once in a pattern. What I need to say is x comma y if x equals y. That's what you can do with a pattern.
One thing to stress about this, and I think you guys will probably know it, but the if goes on the left-hand side of the arrow, and all of these pattern matches are fall through. So the first pattern match that actually matches something, it consumes that event, it consumes that match, so it doesn't go on to any of the others. If the if is on the right-hand side, the pattern, even if it doesn't match, the pattern match has been consumed. It won't continue to other ones. If the guard is on the left-hand side, it doesn't match that pattern, so it falls through to the other ones. And it's a really common mistake for people to put the if on the right-hand side of the arrow or of the rocket, and then things in the pattern match don't work as people are expecting. So, that's just some examples. Sealed classes.
Sealed. You can see the sealed keyword there. It means that this class, this abstract class, can have subclasses, but they must be defined in the same source file. Yeah. So that's how you can, excuse me, you can tell the compiler what all the subclasses are. So it can know what they all are, and then if you pattern match using that type, it can tell if you've left out a possible case. So if you leave out a case, then there can be a runtime error if someone passes that in, right? So that's what sealed is for.
Yep. Options. Now you guys know how to use options.
You should show them. I'll show them a demo of option. Why not? I'm sure everybody knows option, but it's so cool.
Quick
option. Why not? I'm sure everybody knows option, but it's so cool.
Quick option demo. Something like, let's have a. I've already got a case class person, but I want one with an address. So address is. I haven't defined address yet, but I will do that now. So let that fail. Case class address, number, int, street.
That's good enough.
String, zip.
Oh, you want to put
string.
Option of something?
Yeah, let's make zip optional.
Yeah.
Option string, and now I can say val p1 equals person. Actually, sum. Person. So sum is how you create an option of that thing with a value. Some person, Fred Smith, and we will have no option, no address for this guy, so none. Int. Oh, thank you. Yep, I didn't actually recreate that one. There we go. Thank you. Hey, someone's paying attention. There we go.
Who said that?
Yeah. Someone gets a book, I reckon.
All right.
So P1, P2 can be Fred Smythe with some address, number 10 Downing Street. And we'll have a zip code for that of some 1, 2, 3, 4, 5.
Oh, okay, that's
and
fine.
Then, how many? I think that's right. Oh, thank you. Yep. Somebody else gets a book.
Oh my God, I'm going to.
Yeah. Why are we demonstrating this? Clearly, these guys know this stuff. I think maybe we should just move on. You guys can probably see where this is going. Is the for expression? Yeah. I obviously missed one. There we go. Good enough. Now, what you can say is something like for, and what we want to do is p person from p2 semicolon address from person zip from address yield zip.
Yeah.
Duh. Let's actually try putting the things in there. Dot zip. There we go. There we go. So This is, well, shall I say the M word? This is,
you can say an M word,
This is a monadic pattern. The option is a monad. And what it means is, it's sort of like a workflow. What it means is that at any point, the for comprehension can be short-circuited by a none being in there. And it's safe to do so without having to do none or null checks everywhere. This is why options are so valuable. So if I do the same thing on person 1, then we get...
Which should be a none back.
That should be a none back. And it's not an error. It just gets to a certain point and it says, well, there isn't any more. So at that point, the whole expression is going to evaluate to a none. Likewise, if I have val p0 is an option of person equals none, then doing the same with p0 will also yield a none. And that's pretty profound because, as I say, as I like to tempt fate by saying every time I do this, I've been using options for quite a while now. I've virtually eliminated null pointer exceptions in my code. And as a result, it's not just null pointer exceptions, but as Cedric Boost always busts me on, my code is more reliable. It is more reliable as a result of this change of avoiding nulls and always using options. So I can't recommend it highly enough.
All right.
Right. I think break time for 10 minutes. But also question time. We'll stay here, and if anybody's got questions...
Yeah, so we're going to start again in 10 minutes.
10 minutes time.
This is bathroom break.
And this will be best practices time.
Yeah.
Idiotic Scala, as we refer to it. Yes?
From matching, you mentioned these generic types mapped with 2 underscores. Is this just for matching, or is underscores can be used type declaration?
So I'll repeat the question. In the pattern matching example, we gave an example where with map we used what are called existential types. They're underscores. It means that there's some kind of type here, but I really don't know what it is. And they always have to be there, because if a type parameter is specified in Scala, in a Scala class, you can't just miss it out. You can't just leave off the square brackets. You have to have square brackets with something in there. The underscore basically means I don't know anything about it, and more to the point, I don't care. And it's called an existential type. Those are not just used in pattern matches. They're used anywhere where you need something, but you don't care about the inner type. So for example, if I had a trait that's like a list. Yeah, that's a great example, a list. And I want to take the head option, or the head item of that list. Or actually, no, let's just say I want to take the length of that list. All I need to know about it is that it is a list.
Of something.
Yeah, I don't care what's inside of it. It doesn't make any difference to the fact that I can tell what the length is. So I can define a method that takes L, list, square brackets, underscore. And that's perfectly valid. I don't care about the inner type at all. I know there has to be something there for the Scala compiler not to complain that I haven't filled in the type parameter. You could do...
List of any would work also.
Yeah, list of any would work also, yes. But it is different. In some cases, you don't... Yeah, if your type is not covariant, and we haven't really covered covariance. If you don't make something covariant, then if you specify non-covariant wrapper of any, the only thing that will match is if it's got any in it.
The static type has to be any for it to compile. Whereas if you use the existential type...
it will work with anything.
Is this similar to raw types in Java?
Very.
The question was, is it similar to raw types?
It's the way that you cope with raw types.
How raw types are modeled in Scala, it's very similar to that, yeah.
Yeah.
But I mean, one of the 3 things it's used for that are related to Java interop is raw types. That's how you, like the HTTP servlet request returns an enumeration of a raw enumeration. So if you call that from Scala, the way you say that in the type system is you put an underscore from the type. So, hey, there's a guy way up there, yes.
Okay.
Wait, can you speak a little louder? So we
I
talked about
think
what?
I hear him.
Wondering if you can use the manifests to work around the limitations due to erasure in pattern matching.
Oh, can you use the manifests to work around the limitations in pattern matching due to erasure? I do not believe that you can.
Well, the way you do
really.
it, which we didn't mention, is
Yeah.
you say, let's say you match, you say case map __ matches any map. All you care about is a map where the key types are strings. What you can do on the inside of the rocket is another pattern match on the key type. If it's a string, then you do something. Otherwise, now you got the problem of you've consumed the outer pattern match, but that's how you do it, is you pattern match nested. And then it can eventually.
I can think of another way to do it off the top of my head. I haven't tried it.
He's got this
but I think
look on his face like
I
this
think
is
it
not
would work.
something
I'm
you should do.
scheming. One of the things you could do is what I did before with the type classes is store the manifest inside of the type class. You could actually have a pattern guard. So you could say, if you've got a type class, you could say case X of that type class of parameter, some parameter that you don't know about, if the type inside the type manifest equals a particular type. Then you could do it with a guard if you store the manifest inside the type class.
A guard. Okay, why don't we go to you?
It seems that you can't use two the same names of a variable.
Yes.
Can the compiler automatically do the if x is z?
Okay, the question is, we can't use two of the same variable names in a pattern like XX I was showing, and can the compiler not automatically do if x equals y? It does not. It wants you to explicitly state what
Yeah,
I
think it's probably a limitation in the implementation, but it's a natural one. Basically, every one of those things that you do creates a new val in scope with that name. And it's very simply saying, okay, val x equals this, and then immediately afterwards in the same scope, you say val x equals this other thing, and it's like, no, you've already defined that, so you can't redefine the val.
Anybody over here? Oh,
Yeah, it could be more readable. I think the guards are pretty nice. I use guards a lot, so.
anybody over here? Because we probably ignore you guys,
Yes.
especially this one. Who's ignoring us?
It's really hard to see with all the lights on, you guys. If we're ignoring you, it's not through choice. No,
Okay.
I guess not.
All right, so let's see, it was 95.
Did anybody learn anything during the pattern matching one? Yeah? So it was worth going over even quickly. One of the things I find is that I've got used to them now, but it's surprising the number of experienced Scala developers who still see a variable binding and say, what the hell is that doing? They've either seen it and forgotten it or never seen it before. And they see the @ symbol in there and they're like, what is that doing? So I thought it was worth at least reiterating that one.
The other, we'll give you a little bonus, too, for people who didn't need to go to the bathroom, which is that if I have a tuple, I can say val a comma b
Oh, the val,
equals
yeah.
high there, right? High 2. And it will bust it out. What val actually is, this thing is always a pattern match.
Yeah.
So that's a pattern, right? That's a tuple pattern. I could say val person name, well, I guess it's first, last, age equals P1. Oh, I think you might have changed it with address, right? You added address.
Yes, it's address.
Equals P1.
No, you don't need the age. I got rid of age and
Okay,
replaced
let me
it with
get rid of
address.
the age.
Yeah, there you go.
There.
P1?
Let me just do a different one. Val list of 0, comma, a, comma, b, let's say, equals list of
the problem,
0, 7, 8.
The problem is P1 is not a person, it's an option.
Oh, that's
person.
true. Well, let's make P2 then. P2 was a person, right?
No, just do P2
Oh, well, I'll
dot
tell
get.
you what, I'll just say some person.
Yep. Yep.
So it's a pattern, right?
That's a full pattern. Yeah, that'll work.
There you go. So I can grab all. So
Yay.
basically, I bust things out. So it turns out that val x equals 1 is actually a pattern. X is a pattern. It's that variable pattern. Okay, so when you actually define a variable, you're actually doing a pattern match. And that's why you can say in Scala, you can put any pattern here, like that's a constant pattern, right? So I can say val 1 equals 2, and it used to compile. In 2.10, it doesn't compile anymore. That's annoying. All right, just to prove to myself that it used to compile. Val 1 equals 2. This was such a cool little corner. Okay, in 2.9, val1 equals 2 compiles.
Yeah, they obviously closed that loophole.
Because this is a constant pattern. So I guess you can't use constant patterns in...
No, it doesn't.
Doesn't match. Yeah.
But it also
Yes,
doesn't complain.
match. So it doesn't do anything anyway, right?
I think it was
but
probably
did
a good
compile.
thing that it does complain now, at least, because
Okay.
yeah, that puzzler waiting to happen. I don't know if any of you ever saw the Java puzzler where they used I think it was a lowercase 1 instead of
A lowercase 1?
No, a 1 instead of a lowercase l. But the font that they chose, you couldn't tell the difference. So you look at this thing, and it was very sneaky. It was actually 32 long with a lowercase l instead of a 321. And so when you read the code, there was no chance you were ever going to guess what the right answer was because they used a font where you couldn't tell the difference.
Bummed I can't say val1 equals 2 anymore.
Right.
Okay.
Am I talking?
Another
Oh, yes,
2 minutes.
I'm talking.
Yeah, I think you can talk. So
Okay.
I think we should wait 2 more minutes because I did say
Okay.
10 minutes. So what else can we... anybody have another question? One more question before...
Did everybody really kind of get type classes?
Yes.
Are type classes
Oh, good. Type class question.
are always with one type?
Type classes are always with one type. I think that's sort of the loose, that I'm not sure of. You can certainly do things that look like type classes with more than one type parameter.
but a context bounds is
But I
just one.
think that the generally accepted definition in human terms of what a type class is a class with a single inner type in it. I would need to check my references on that one. And the compiler doesn't care. The compiler has a set of rules that it follows. But I think when developers are talking about type classes, they mean a single class with a single type inside of it. And that's certainly the way I think of it, is when I create a type class, it is for a specific type, not a group of types. So that's a good question, though. Yes?
In the example with the pattern matching on the val, what would happen if P2 was a none?
If P2 is a none,
If P2 was a none?
if P2 is a none, you get a, well, do it. Yeah. You get a pattern match. Actually, that's a, oh, you need, it can't just be none. Use P0. Yeah, that's a match error.
Thank you.
So in the first case, it was able to tell it didn't have enough type context. It didn't know that what we had was an option of person. None itself is just none. So it didn't. That was able to tell it was a compile error. In the second case, though, where P0 was actually defined as an option of person, so it had that type context there. Oh, there it goes again. It had that type, maybe it's type context that sets it off. I'm going to start the buzzword.
Yesterday it was var, but
Yeah,
today
I'm going
it's...
to start the buzzword thing and see if I can guess which word it is that sets off the alarm. Yeah, in the second case, it's the types match up, but it's not a pattern match, so you actually get a match error. It's a runtime error when that happens. So that's something worth knowing, worth bearing in the back of your mind, is vals can sometimes give you runtime errors in Scala if you use pattern matches. That may not be used to coming from another language. Okay. Idiotic Scala.
So yeah, you tell the story about Idiotic Scala.
So when we first did, we've been doing this training for quite a while now. We've done dozens of these at this point. One of the early ones, there was a company we did it for that shall remain nameless, and a gruff manager of that company who shall also remain nameless. He was a nice guy, but quite gruff and very matter-of-fact. And, he was obviously in charge of the beans and wanted to know why a couple of people charging so much money would have to come in and teach his people. Anything would have been a lot of money to this guy, I think. And one of the things, as he was walking past one day, he sees up on the screen Idiomatic Scala, and he then does a double take and comes back into the room, and he says,
he walked past
"Why
the doorway
are you
and he
teaching
comes
my
back."
people Idiotic Scala?" And at which point we were like, and then he looked at it again. And so since then we've always called this Idiotic Scala. But what we should say about this is we're kind of moving into the best practices portion, which is something that people have asked for since we started doing Scala training. One of the problems with best practices is that they not mature, they change. They shift over time. what was best practices yesterday may be considered a bad idea, and that's happened a lot in Scala. So the first disclaimer on this is stuff that seems to work for us right now. Any and all of these ideas could turn out to be a bad idea when people think about them a bit more, and some of the things that we've already talked about have turned out to be a bad idea. You know, an example is implicit conversions. They were approved for a long time, but now, you know, patterns like type classes and implicit classes are a better way of doing that. And I think it's healthy that a language has this kind of change in it. I think if something that's really held back Java is its inability to change and drop the bad ideas over time. So I like living in an ecosystem where stuff changes, but it is bewildering. It's like, oh, you know, we've been telling people to do that, and now it turns out that's a really bad idea. So anyway, given that, here's some things that we find work for us. This one's a really simple one. Try and favor immutability whenever you can, and Scala will help guide you into this. So instead of using vars, try and use vals. A trick that I use, and I picked up this idea, stole it wholeheartedly from NetBeans, but I have a color scheme that's actually freely available. I need to blog it or something so people can download it. I have a color scheme for IntelliJ that turns all the vars in my code red. Okay? It's not a compile error. They just show up in the source code and they're red wherever you use them. And it's just it's like a little cattle prod of, you know, a little zap every time you use one of, maybe I shouldn't be using a var there. Is there any other way I can do this without using a var? And the other thing I do, though, is anything that's public, any var that's public on a class, that gets a red, bold, italicized version. That's like, oh, no, you shouldn't be doing that. So anything that's part of a public API should never be a var. It's okay to use a var internally, but there's usually another way. So that's just a little trick. Here's an example. You can usually find, when you get good at this stuff, you can usually find a way of not using vars. One of the things that you can do, though, and it's worth mentioning, is kind of the minimal scoping var. So sometimes you do actually want to use a var, but you definitely don't want it to escape. So what you do is you actually, if you can go back to that really quick, what you can do is you can make a val, and the val is the result of some open curly braces, and then you create a var, and you do whatever you need to the var, and the last thing that you do in that code block is put the name of the var in there. And that's the expression that gets evaluated. Once it escapes that code block, it's a val now. It's no longer mutable. So you've made a var long enough to do what you need to do, and then it becomes a val.
Right,
it is the var again. Someone is messing with us, man. Someone up there in there is like listening for var and is going, woo. So
anyway, so there's often a way to get rid of the var. Just anyway.
Yep. But yeah, the minimal scoping thing is quite neat. Likewise for a similar thing for collections. If you use mutable collections, try to avoid those. But if you need to use them, you can always convert a mutable collection to an immutable collection before it escapes some kind of scope. So if you need to use a mutable collection, make it up, convert it to immutable, and give it back. And mutable collections in particular are evil. If you hand them around or make them part of a public API, if you do that for a reason, you really need to make it clear in your documentation that that thing's mutable. Because I think most people in the Scala world are going to assume that it's immutable and it's not going to change, and they're going to base their code on the fact that it won't change. So
yeah, and there's one thing I think is a good
quite
time
dangerous
to bring up that I just sort of became aware of about 2 weeks ago. I think I probably kind of knew it in the subconsciously, but when you say map of 1, 2, 3, 1 map of 1, 2, 3, 1 to 2 or whatever, that gives you a Scala collection immutable map. If I say set 1, 2, 3, I get a Scala collection immutable set. But if I say seek 1, 2, 3, I don't get an immutable one. I get a general one that could be mutable. So if you make your return type seek,
it's a list,
then that means
it could be an array.
It could be
an array.
Mutable. So with seeks, you got to actually say you want an immutable one.
Yeah.
So that's just one thing to know.
Yep. There was one thing I was going to say on immutables too, but it's gone. It's blame it on the jet lag again. Okay, let's keep going. Maybe I'll remember it. Avoiding nulls. We mentioned this in the last one. I really have a war against nulls now. I go through code, and if I see a null in there, the way I look at null at this point, it might sound extremist, but believe me, after a couple of years, it will probably feel the same to you. A null is an error that's just waiting to happen in the code. That's the way I look at them now. They are a time bomb. A null will eventually go off. Okay? Get rid of nulls from your code. It's just there waiting to cause trouble. It's one of those things. So one thing in particular is when you use vars. If you don't use vars, you never have this problem. But with a var, there's a convenience thing in Scala where you can initialize a var to underscore. It means I don't really care what you put in here. Guess what? I don't really care what you put in here. Guess what gets put in there for an anyref? An anyref gets to be null if you do that, because it doesn't know what else to put in there. So that's something to watch out for. Nulls are insidious. They sneak into your code and they actually cause a null pointer exception in there. That's the best that you can possibly hope for from a null. Null is not your friend. So, okay, idiomatic options. This is what we just showed, actually.
This, yes.
So we won't spend a lot of time on this, but yeah, the naive way to use options is to do pattern matches of some and none. Much more effective is to use a for expression.
I would
love
call it
for
naive.
expressions.
I would just call it straightforward or whatever. I think
Yeah,
people,
it's
when they
the
first
first
start
way.
out,
Yeah, it's
they
the
tend to
first
do
way,
that.
yeah.
And the for expression doesn't make sense. And I
Naive
think that
is
the
not
way to
wrong.
think about it,
Naive is not a negative thing. It's just it's a first approach.
Okay.
So
The way to think about options in for expressions is you can think of an option as a collection that can either have 0 or 1 element. So you can think of it as a list with either nothing in it or one thing in it. And then if you think of it that way, iterating over it through a for expression does kind of make more sense. As soon as you hit a list that's empty, then the rest of the thing's going to be empty all the way through.
yeah, that is a really good analogy. Is think of an option as a collection with at least one, with at most one thing in it. Okay, knowing for expressions is just good style. It's good thinking. I've seen so much code, and you know, this is a temptation. I think we've all been through it. I've seen so much code that chains together about 6 or 7 flat maps, filters, all that sort of thing. And you look at it. Even I look at something I've written and go, "What the hell is that doing?" A for expression is almost always clearer. If you've got more than like 2 of these things chained up, a for expression is going to be more readable for somebody looking at your code, in my opinion.
And in my opinion.
Yes.
But this is just our opinion.
These are our opinions, but they're good opinions. So a for expression is definitely worth...
in our opinion.
In our opinion.
They're good opinions.
Yeah, they are good opinions.
So yeah, in most cases, Dick and I kind of independently came to the same style. In a few places, they're different, but this is one where it's the same. If it's, I do use map and flat map, well not flat map, map and for each. I call that on things. But if I do more than 2, I tend to switch to a for. And then for, the other thing about for is you can see these guys stacked up. If it's just 1 or 2 things, I'll put it all in one line. Otherwise, I start stacking them. So. Like this one back here, you've got some fours. This is okay, but if you get any bigger than this, I would tend to start stacking them.
Yep. So I think that's good for that one. This is another one. Actually, this can be broadened to not just using map or flat map instead of for each. For each is non-functional. Okay, it has no return type, so it has to have a side effect to do anything useful. So you want to avoid for each and use map or flat map instead. Likewise, you want to avoid for comprehensions or for expressions without a yield, because that's the same thing. Okay, they have to, in order to do anything useful, without a yield, you need to side effect something. Whereas if you've got a yield in there, it can be functional. You can avoid side effects and return something new.
So yeah, the way I describe this is that use the functional way by default and use the imperative way if you have a special justification for it. And there's nothing wrong with, if you have a justification, then use it. But the default should be to do a map instead of a for each, and use a for each when you have a special reason to do it.
That's a good point in general, is Scala gives you these tools for a reason. Okay, it doesn't shut them off. Like a language like Haskell, you have no choice but to do it functionally. The alternative simply isn't there. Scala has made the decision not to impose those restrictions upon you. It's relying on the fact that you will do what you need to do. The better way, the idiomatic way, is to try and reach for the functional way first. But if you have a reason, those tools are there for a reason. So
they're not evil.
They are not evil, they're just not recommended.
The one other thing I want to say about for each is with parallel collections, if you actually take a gen traversable, for each on a parallel collection actually can run the thing in parallel. So now you got to worry about thread safety. So that's just something
with
to
a
keep
side
in mind.
effect, that's a very bad thing, usually. Okay. Oh, this is just. There's some things that, in particular, I wanted to mention. Stuff like sometimes it appears that you actually need an index for some operation. So a lot of people, the traditional way, going back to C and C++, you always had an index. You had an int I from 0 to whatever, and then you did things in terms of that integer on an array or something like that. And you always kind of did these things as indices. And sometimes you still need an index. And if you just have something that maps over the items in a collection, you don't have an index there, and sometimes you actually want one. Well, you could go in and do a for from 1 to 5 or something like that, and use a range to do it. The alternative is to use something like zip with index, and what that actually does is takes a collection, takes all the items, and adds an index number to each of them. And the advantage with doing something like that is it then could be parallelized still. You get a tuple of the item and its index. You could reassemble them after some parallel operation has been done in the order that you want by sorting by that index. But because you're not using a range, you haven't forced it into single execution thread. So that's just another one to kind of think is use zip with index instead of a range. Map or filter methods versus for expressions. What
I think we kind of said this. If we do, if you're calling map or for each or filter individually, then a few of them are okay. If you actually want to do that, like if you really do want not like for expressions, I think that the guideline there would be just don't string 20 of them together. String 1 or 2 together and put it in a variable with a name, like an intermediate step name, and then just have a few vowels like stacked up.
I see. Yeah, this is just general rules. Yes, actually a general pattern that I use, or one of the things we haven't mentioned, I think it's in here, is on any public API, always specify your return types, even though you don't have to in Scala. It saves so much effort and time and debugging weirdness if you just say, this is always going to return a string. And actually there is one in here, so I'll show that. But that's one of them. And likewise, if you have a bunch of transformational stuff going on, go ahead and stick vowels in there with the expected type on them. It helps people reason about your code. And Hotspot will get rid of all that stuff anyway. So you're not paying any performance penalty, you're just making it more readable. Okay, next one.
The other thing is that if you put return types on public methods, it may help your compile time, because
that's right.
Type checking can be quicker than type inference.
Yeah, quite true.
And the other thing is that the type inference can generate types that are more complicated than what you would actually put there, and that too can sort of add to the compile time.
Symptoms of that are occasionally you'll see a compile error along the lines of required string, but got char sequence with Fred with philosophize with that on it. And that's the result of the type inference has done its job and it's given you the information you need, but it's not really the thing that you want to be your type API. So if just go ahead and specify it. It makes life easier.
So then this partial function thing.
Partial function, this is an example of pulling out. So the bottom one, if you iterate over a map or anything that's a list, anything that's a list of tuples. So a map, when you iterate over it, it gives you back tuple 2s, just key and value pairs. One of the ways you can do that is to bust them out, is to use a pattern match and just say case k, comma v. So that, case, key, comma, value. And that actually pulls out the two things from the tuple, rather than using _1 and _2, which is a lot less readable for somebody coming behind you in the code. Most of these tips are because that's really what matters in Scala. Okay. This is a great one. I use this all the time. So one of the problems with exceptions are neat. Don't get me wrong, I'm not exceptionist. But they are a pain in that they interrupt control flow or program flow. Okay, an example of this is I've got a massive number crunch to do, which I do a lot of in Scala. I get most of the way through some kind of calculation, and then there's an exception. And all that work that I just did for the last 2 hours gets thrown out the window as this exception pops back up the stack and says, hey, it went wrong. Good news, you get nothing. So one of the alternatives to this is usually I want the vast majority of successful results, and I want to know when things failed, but I don't want it to say, hey, it failed. And what I want it to do is give me back the results that it was able to give me, and then any failures along with those. So instead of throwing an exception, what you do is you use this other monad that's available called either. And what either has is it's got either one thing or the other. It has either the correct result. I do it all the time now. You've done that to me. I switch between my eithers and either. But it either has the correct answer in it, or it has a reason why it failed, and that typically is an exception. But instead of throwing the exception, you chuck it in the left side of this thing. So this is a type that has a right side and a left side. By convention, the right answer goes in the right side, and anything else goes in the left side. Okay? And then what you end up with at the end of all this is you end up with a collection of either the correct answer or some reason why it failed. You can have 1 million of these things. You might have 5 of them that failed in some way. You've got 9,900 and whatever it is, 95 correct answers and 5 failures. And you can say, yep, pretty much everything worked. These 5 failed for these reasons, but I got you your results. Okay, so this is a type-safe way of dealing with exceptions that occur without losing control of the flow of your program. And that's a really nice feature. And when you've got, and there's some examples on the next few slides, I think, you can still do operations on eithers by mapping into them. They're monadic. This is the definition. If you're interested, the definition of a monad, pretty much in terms of technical definitions, is that it has this flat map operation on it, which means that it can do something to the contents of it and carry it forward if it's there. And if it's not there, don't sweat it. Don't throw an exception. Just leave it as it is pretty much the way that you can look at that. So if we get the right answer, with the right answer, we can say, oh, sorry, can you...
Sorry, do you want to go back here? Sorry.
Just quickly. With the right answer, you can say, make int 5, with the right answer, map it times 10. So if I've got the right answer, multiply it by 10. If I've got the right answer, multiply it by 10. If I've got the wrong answer, it will still be the wrong answer. And you just carry forward the operations.
Here's an example
like
of an inferred type. See that?
Yeah, there you go.
Really, we just wanted an either of string int, but what we got inferred was serializable with product with scala.util.
Yep.
Util, anyway. But I got right 50 in that case, but when I say make int Fred, which is not going to work, sorry, it's hard to copy and paste from here. It's going to give me an...
it's not an exception, it just carries the error forward. It says, hey, it still didn't work. Same error. So that's a really nice pattern that I use all the time. Alternatives to loops and mutables. I think loopy mutable code is, at this point, definitely a code smell in Scala. I think when I've got some great examples of kind of non-functional programming where you have, one of the best ones I have is a method that existed in some real code I worked on that was about 150 lines long. And it is like a picture of a mountain range on its side. It just goes up and down and up and down.
That's up and down a lazy river.
Yeah.
I think of it as floating down a lazy river.
Yeah, like floating down a lazy river, yeah. Floating down a lazy river code, it's pretty much untestable. Okay, trying to cover all of the different possibilities for testing that thing, really hard. So the more ifs and loops that you can eliminate from code, the more higher order functions you can use, where you define the inner function and test everything about it, and then you know that the higher order function has been tested like crazy, so you really don't need to test that. It all saves you work. So that's a good example. Here's an example of some mutable code that is creating a factorial sequence. It's quite efficient, this code. It creates a factorial sequence where, you know, if you ask for a sequence of length 8, it gives you the first 8 factorial numbers, and it does it by, you know, by keeping a running count in a var, multiplying it each time by the last one, all that kind of thing, and gives you the result. Very efficient code, very fast to execute, but not very functional. So next one, this is pretty much a full-on functional version of that. And there's a few things. The yellow stuff is what matters, some tricks. I've made it tail recursive, so this will be almost as efficient as the last one. The only place where this isn't as efficient is in the reverse, the excess.reverse. So what I'm doing here is using the nature of a list, where it's faster to add things to the head than the tail. And that means that if I want the thing in the right order when I get it back, I have to take that list and reverse it before I hand it back. So it's in the order that I intended it to be returned in. That's the one overhead to this one. Another way to do this now that's actually very efficient is to use a vector. It's immutable. We haven't really talked about vector, but actually that's another good idiomatic thing to mention. If you want to do something like this, and a list would mean that you have to work not at the head or you have to do a reverse, use a vector. Vector is an exceptionally good immutable functional data structure that's available.
Yeah, that's
in
an
Scala.
example of something that kind of changed over time, because originally list was the thing, and it's a very nice functional data structure, but it's very efficient if you work only at the front.
Yeah.
Do head and tail and that sort of thing.
Vector.
The problem is, in practice, in the heat of battle, it's easy to forget you're working on a list and just use things that are not constant time. So vector came in, and it's actually it has better performance characteristics. You don't have to remember not to use it except at the front.
Yeah.
So I think list is good for functional algorithms. Otherwise, the default sequence is now vector.
Yeah. And vector is
opinion.
it's effectively constant time for every operation that you can do on it, which is quite remarkable. And it's also just through a lucky happenstance with the JVM. It happens to really suit the JVM memory model as well. So as well as cleaning up on the fact that it's a very clever implementation that makes everything nice and constant time, it also is really fast because it allocates memory in chunks that the JVM likes, and ends up being even more efficient. You get even more gains than you would have got because of this lucky coincidence. So Scala annotation tail rec means that this is tail recursive, so it turns into a while loop behind the scenes. The default named parameters I used to initialize some things so that I can call this with just one parameter, but it starts with those initial values. And then the whole thing is recursive, and it uses factseek, and basically what this does is it sticks a new thing on the head, and then it recursively calls the next thing with the current iteration number times whatever's on the head of the list already, and adds that to the head of the list, and so on and so forth. So that's kind of a full-on functional algorithm style for that implementation.
Yeah, so the tail rec annotation is important for making sure you're sure that it is tail recursive, even though you think it is. It's also useful for documentation. When I look at your code, I can see that it is tail recursive. The thing is that I can't tell that you know that it's not tail recursive. I wonder if we shouldn't have a not tail rec annotation.
Not tail, yeah.
Just to say that I know this isn't tail recursive.
Get a warning otherwise, or something like that. Yep. Okay. This is just general advice, but knowing your collections is about the best thing that you can spend time on. And particularly when a new version of Scala comes out, be sure to scrub the Scala docs to see if there's any new stuff in there. One of the examples of this is I had a problem that I wanted to solve that involved transposing a matrix. Okay, you know, that's taking the diagonal and kind of flipping. Okay, you know, that's taking the diagonal and kind of flipping the matrix around the diagonal like that. And so I sat down and I wrote a transpose operation on a sequence of sequences. I thought, yeah, this will be fun, you know, do a little for loop and stuff like that. A couple of days later, I discovered that there's actually a transpose method in the Scala collections that was written for me. It only works on sequences of sequences, but it works beautifully on them, and somebody did it for me. So a great example of, you know, if it's something you think you need, there's a good chance it's there already. You should go and have a look for it, and just spending time getting familiar with the collections library is a really good idea. I think we had a bunch of...
If you find yourself saying, I wish there was some method that something,
yeah,
just
have a look.
Implement it.
Yeah, some of the things like sum and product are defined on anything that is numeric, a collection of anything that's numeric. So you can just say, give me the product of all these things. And that's compile time. That's the beauty of this. Because of those kind of implicit tricks that we showed, the context bounds that we showed earlier, it will only compile for things that it knows are numeric inside of a collection. Otherwise, it's a compile error and things like that. So yeah, make string, find, filter not, all these kind of things are just there's a wealth of value in the Scala collections library.
Yeah, I think really getting to get good with collections is getting
good with
Scala.
A
big part of getting good with Scala.
Yeah,
I think.
Yep.
So
what's next? This one's the one I was talking about. Whenever you have any kind of public method, whether it's API or not, even if it's just internal, stick a return type on it. This is a great example of what happens, and I did this all the time. Okay, what I'm intending is to have a safe division at the top, where I return either the division, the result of the division, or none if it didn't work. Okay, the problem is I forgot to put sum around my n and d, my n over d. It looks right, because I've got none in the other place, but it's not right. What this actually returns is an any. I think I heard somebody say it. The only super type of a float and a none is any. So the type signature of this is int to any.
I can actually show you.
Okay, and that's not what I expect. Now the problem is when I come to use it, it compiles, because Scala's type inference is like, yeah, you know, obviously you know what you're doing. So it's like, yeah, you know, obviously you know what you're doing. So you return any from this thing. When you actually use it, oh, that's different now.
Yeah,
I think.
I was just curious which.
But what? Yeah, what's the error?
It's now no implicit view available from any to gen-traversable once.
Yeah. Well, that's because you're trying to use it as a flatten.
Well, that's what.
Oh yeah.
Well,
oh no, that was mapping.
Similar.
That was mapping safe dev. Yeah, but anyway, what you get is you get this. Could not find implicit value for blah 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 to convert this thing to the type that you want. Not very helpful. But if you put the actual expected type on it, then it tells you exactly what's wrong at the definition site. So instead of being off somewhere in some other code that's trying to use this thing, you get an error right there about what's wrong.
So usually the less typing or finger typing thing is the idiomatic way to use Scala, I think. Yeah. But this is an example. And it's not every method, but it's public
Pretty
methods
much.
and classes is where I do it. I don't often
I can also
always
consider it as part of the documentation of my code is the expected return type of this thing. So that's the other way I look at it, is I'm not anal about putting types in my code, except when it's a return type of a method. Okay. Consider case classes for more than just match. This one, if you've got anything that might be treated as a value class, go ahead and see if it can be made into a case class. Case classes are wonderful. They were, for a long time, one of my favorite features of, well, they are still one of my favorite features of Scala. And the restrictions on them, and this is another change in 2.10. It's now a compile error, though, if you try and extend one case class from another case. If you try and extend one case class from another case class, try it. This has been deprecated for quite a while because it messes up equals. And I think somebody managed to prove that there was never any way to get equals to work exactly right. So now the auto-generated equals doesn't work for case classes that extend case classes. And now I think it's actually a compile error if you try and make a extends.
Subperson, extends superperson.
Yeah. Extends.
Superperson of 0.
Yeah. Let's see. I think
See
this
what
will
it
be a
does.
compile error now. I'm pretty sure it was. Yeah. Yep.
How are we darned?
So they actually
Okay,
look
that's
for this
good.
now. This is something that it just can't do reliably. So this is one of the limitations of case classes, is they're best used in something that's like a reasonably flat hierarchy. Certainly you can't have another case class in the inheritance hierarchy. Typically speaking, I think anything above like one superclass for a case class is probably a bit suspicious. It's quite natural to have a single superclass for a case class, but not more than that. Yes, Peter. Does it work for abstract case classes? I don't think you can have an abstract case class, can you?
You can. Well, I don't know. Maybe you
well,
can.
we should check it.
For instance, if you've got a node and you've got, say, an entity which is an object and just one
No, you can.
kind of leaf node that represents the real thing.
What you would do is the super would not be case. That's all. So what you tend to
Yeah, you just don't make it a case class if you want an abstract superclass. You can do that quite happily. And then just extend it as a case class. But the case class should be your leaf.
usually.
And usually speaking, if there's an inheritance hierarchy that's of depth higher than 1 that you're using in a case class, that's kind of
It's questionable, but it's not
code.
wrong.
Yeah.
Right? So
I think that's the case. If you do an abstract case class, it has to be on the same file where you extend it.
Can you?
no, that's
I don't
sealed.
Think, well, you can't.
That's sealed.
You can't extend
No,
a
you
case
can.
class with another
Actually,
case
it
class.
just has
now.
a little bit of history here. Let me get rid of it.
I don't think you can have an. Can you make an abstract case class? I don't think you can.
Yeah.
Can you? Oh, you can.
You can.
Well, what
But
use is
it's,
that?
it's one of those things that Scala is orthogonal. It doesn't have special rules. If you can make a class abstract, you can make a case class abstract. even though it doesn't
what that's
necessarily-
useful for is you can. That's right. You can extend a case class with an ordinary class. That's allowed. So
Yeah.
that's why they allow it, because you could make an abstract
I'd
case
say
class
class
and then
sub.
extend it. Yeah.
Well, this isn't a case class, but let me get rid of the history again, and just say I'll make this a case class. You can say class sub
yeah.
extends.
That's fine. And that could be
Superperson.
useful in some weird circumstance.
Yeah, but that's very. Normally what you have is an abstract super trait or super class, or even usually it's abstract, and then you have the subclasses be case classes, and those are the leaf nodes, and that's what you usually have.
Yeah.
So you can add an extractor. You can write your own extractor for these other
Yeah.
types in the hierarchy, and that's what they recommend you do. If you really want like be able to pattern match on case superperson, well, let me if going back to the original where superperson is abstract like this, abstract class superperson, and then the subperson is the case class. That's what you would normally have.
Yeah.
Here, if you actually want to say case superperson, flying speed, FS or something, in a pattern match, what you need to do is write an extractor
Yeah.
in the superperson object
And if we
by
get,
hand.
I don't think we're going to get to those today, but there's a chance that we might if we're quick.
I don't think so.
So, okay. So anyway, case classes, the point of all this is case classes, if you've got a value object and you've got a flat inheritance hierarchy, seriously consider whether you can make this thing a case class, because you get a lot of stuff for free. One of the things that this is another ticky time bomb bug that I consider, just like nulls. If you've got anything that looks like a value object that doesn't have equals and hash code defined on it, that's a bug waiting to happen. At some point, somebody's going to stick that in a collection, and it's all going to go horribly wrong. So if you've got anything that looks or smells like a value class, it should have an equals and hash code on it. If you can make it a case class, you get those for free. So that's just another thing to consider. Okay. Right. This is a great one that I think is really nice to mention. A lot of people return tuples from methods because they want multiple return arguments. Consider returning a case class instead of a tuple. It makes the code a lot more readable. Here's an example. The problem with tuples, with return tuples, is that unlike parameters coming into the class, tuples don't have names. The values in them don't have names. So you're not sure what you're getting. And an example of this is from some real code that I was working on. I have a calc method that takes two alleles, which are genetic-y things, and it returns a double, and then an inner tuple of Boolean. And I'm like, what the hell is that doing? I have absolutely no idea what those two things are, the doubles and the flags, and what a weird structure, and just, it was very, very difficult to read code. What I did was I dug into the code and found out what, what it was actually doing, and then I rewrote it to create a case class that is the result of this calculation, and it has the names of the return, the return things, the return arguments in it. And so it turned out that it was R squared D prime, and whether it's valid and whether it's linked. Those were the things. Now I can see that, and I can still pattern
Bust
match
it
on
out,
it.
yeah.
I can
will
still
show an example. What it would look like
pattern
is,
match on it if I want
what
to.
do you call the thing?
LD result.
So you can say this now. So it's very similar to the way you can bust out the pieces of a tuple. It's a pattern match, so you can bust out the pieces of a case class.
It's
it's
very
just more
little
obvious.
extra finger typing for a lot more readability. So that's a good one to do. Okay. I'm not going to go into this a lot, but traits over classes, main things to consider. Traits can be mixed in. You can have multiple inheritance with them. There can only be one superclass. So if you make a superclass, you've immediately killed anybody else from being able to.
Class.
Yeah, you've burned the base class at that point. So if you can make it a trait, make it a trait. Things to remember, traits can't have constructor parameters. There's some workarounds for that, but there's also some gotchas with those workarounds. So
And
if
they're
you
ugly.
need, and they look ugly, So
Well, I mean, they're not, but it's just...
traits if you can. If you can possibly make something a trait, do it.
okay.
Okay? I think we can skip that one. Consider it, pattern matches. I love pattern matches, particularly if you get into a situation where you get an if, else, if, else, if, else, if, else, if. Those can always be replaced by pattern matches, and they end up looking much nicer as a result. Remember that you've got guards. Remember that the guards go on the left-hand side of the rocket, and you can make things look a lot nicer. One trick that I use occasionally is if you have if statements with multiple things that are being matched in them, you can actually stick the multiple things that you want to match into a tuple and pattern match on that. And you can say, well, the first thing's got to be a number between 5 and 10, and that kind of thing. You just bust them out of the tuple in the pattern match. So that's okay. Functional literals and closures. I think we've mentioned this when we talked about it yesterday. Try and avoid having a closure over mutable state. Okay, Scala's a fairly unique language. Well, Scala's a fairly unique statically typed language in that it's one of the few that I know that allow both closures and mutable state in a closure. Most statically typed languages, either like Java, they only let you put finals into an anonymous in a class. You can't put something in that's not final for this reason. It's occasionally useful, but it's also quite dangerous. So take an immutable copy. Remember that you can serialize closures or function literals, but serializing them only works if everything that is inside is also serializable. So you can get serialization errors if you are not careful. Biname functions, if you've not used the biname function, it's basically a parameterless function that you can drop the parens on, so it looks really pretty in the code. They can be really good. The downside to those is if you overuse them, you end up massively slowing the compiler down because everything becomes a separate class, and it is a real problem in terms of performance. So use them when they make sense and when you need them. Don't overuse them. Implicit conversion from interfaces, that's the pimp my library that we saw earlier. And, the next slide is a good one. Something like this, where you use code. I don't know if anybody knows, this is a little bonus, but if you want to check for an even number, a bitwise comparison with 1 equals 0, that's much faster and more efficient than doing a modulo 2 equals 0. Just a little tip there. It's an evil premature optimization, but you know what? It's kind of a neat one. And the thing is, I always forget about this one, so I always do mod 2. What you can do, instead of having to remember it each time, is create a convenience filters method, filters object, with a bunch of these handy things like this defined in it. And then what I can say is, filter is even. I import that thing, and I use the eta expansion that's part of Scala to give me something that's very readable without having to type in x_1 or underscore _1 equals 0. I just say filter them where they're even. And it's a nice readable way to do that. So remember eta expansion.
So eta expansion, what that means is I'm actually supposed to pass in a function object here. And what I'm saying is the name of a method. And Scala will look at that method and see if it has the right signature, input and output. And if so, it will wrap it in a function object. That's the eta expansion. Eta.
Yeah. Okay. Currying for function parameters. This, particularly combined with a byname, makes for something that looks very much like Scala syntax. So here's an example of a do times method where you just say do times 5, and then you give it curly braces, and that function, whatever you pass in there, will be done 5 times. That's a pretty neat little pattern. Nothing more to say on that, really.
Okay.
Scala annotations, a lot of things that are keywords in Java are annotations in Scala. Just know them. Volatile, in particular, specialized, native transient, all of those. Ones that are worth calling out are bean info and bean property. If you work with a library that requires the Java beans pattern, stick bean info, stick bean info on the class, or stick bean property on the fields, and it will generate your getters and setters for you, so that you can use them easily with those things that require those patterns. Okay?
The two I use mostly are tailrec and occasionally volatile.
Yeah. Java converted. Okay, so there's 2 ways. I don't know. The slide disappeared, but I can talk about it really quick.
Use words.
Yeah, Java converters and Java conversions. These are implicits. Java conversions is now kind of frowned upon. It automatically converts a Java list into a Scala list, for example, or something like that for you. The better way to do it now is Java converters creates wrapper objects where you say a Java list, whatever it is, xxx dot as Scala.
I'll just demo it.
And that's an xx dot as Scala.
I'll just demo it.
And that's an explicit it's an explicit request to convert it to the right type. It's easy to use, but it doesn't happen accidentally when you're not expecting it. So Java converters is recommended.
Yeah. So
over
Java
conversions now.
Underscore, or is it? Oh. Did I spell it wrong?
Scala.collection.java convert. It's ER.
I spelled it wrong. It has to be. Yeah. Okay.
It's ER, not OR. That's it.
Okay. So then, I could say val x as colon. I want this to be a java.util.list of int, let's say.
Yeah.
And then I'm going to initialize it with a list, a Scala. Oh, I can't do that.
No.
Let's make it a list buffer. That would work. Buffer of 1, 2, 3. It won't work, but I can just say .as Java.
Yeah.
And the
not found list. Oh, mutable.
Oh, import Scala.collection.mutable. Sorry. And now it would. Actually, the first probably complained about that error before also. So there it says I have a type mismatch. That's what I really meant. But if I say .as Java, and where .as Java comes from is it's implicitly converted via something in Java converters.
Yeah.
So what this does is it makes it explicit in the code where they're converting back and forth from Scala to Java, and that turned out to be preferred in practice to the conversions, which it was implicit. It just happened
magically,
yeah,
and
magically.
That led to a lot of confusion. Sometimes things were happening in a different order than you would really want them to. It would convert, if you had a chain of these things, it would convert one earlier than you thought, or later. Actually, it was usually later than you thought into the Scala conversion, into the Scala collection. And it caused all sorts of trying to reason about the code. Much better to have an explicit convert this to Java or convert this to Scala.
So the other one that we're missing is implicit classes. Oh, actually we
kind of talked about that, right?
So, yeah.
Yeah, the new one is use implicit classes versus a class with an implicit conversion. That's only Scala 2.10. You can't do it in Scala 2.9, so you've got to wait for Scala 2.10 to do that. But that's the new recommended hotness.
You know, some of our slides are a little busy, I think, a little verbose in this one. So
I like that.
This helps the average.
This is the Zen slide.
I don't know what
It is the contemplate the emptiness. It is the pot. The pot is an object,
Yes.
but it's the emptiness inside that makes it useful. That's a Zen koan right there.
Yeah, that's
See?
a good ad for our cones this afternoon.
Yes.
Sorry.
Yeah.
This is the last slide.
Last slide. I mentioned I have a syntax coloring scheme that turns my vase red. I really like that. You guys are all welcome to use it. I need to put it up on a blog or something somewhere. Sorry? I didn't do it for null, but now you say it, I think
that's
that might
because-
not be a bad idea. I'll see if I can do that. Yes, actually, that should
Null,
be...
what you should do for null
I'm gonna
is
use
not
a
only
blink
make
tag.
it red and bold and italics, but change the font size to 5,000 or something.
Yeah.
So it's like...
I'm also going to make it a
and
blink tag.
Yeah, you can make it blink.
Well, yeah, the most obnoxious thing I can think of. Pair programming with another Scala developer is really good. It's a really good thing to do. There's so much of Scala to learn. I will spend a lifetime trying to learn it and never learn everything about it, I'm sure. Pair programming with somebody else is a great way to pick up stuff really quickly. One of my happy memories is Java 1 a couple of years ago. I actually managed to get some time to sit down and work with Paul Phillips, who's the guy who works on the compiler. And it was pretty much like he levered open my skull and just threw a bunch of stuff in and jumped down on it, and then closed my skull up again. It was an incredibly valuable few hours for me. And I'd like to think he got something out of it as well, but he probably didn't. But, you know, just that kind of chance, you should always take it. It's really, really good. Sweep through code as a relaxation exercise is something I do because I have no life. Look for patterns that work well in your own code, and look for anti-patterns that, in particular, anti-patterns I think are more important than patterns. Things that you shouldn't do. Pass those on. Avoid things to avoid. Right.
Okay, let's take a few questions while I switch to the next one.
Okay.
5 minutes of questions.
Yes. Oh, that's very greedy. I think.
First, you mentioned either. There's this validation thing in Scala Z.
Oh.
Give a quick note.
Yeah. Actually, that's that. I'll expand on that topic briefly because I know we're running a bit late.
To repeat
the question is, I mentioned either as the kind of general right answer, wrong answer mechanism. Scala Z has a more targeted implementation for things that you're expecting and things that you're not expecting. Actually, so does Twitter. Is it Finagle or one of their libraries has the...
It's in util, I think.
It's actually in util now. Okay, they actually have a try-catch monad now, which is very much like either, but it's totally intended for try this thing, and if it fails, here's what you do. But instead of actually throwing and changing the control flow as a result of the exception, they pass up the exception just like either does. I think they're great. I use either because it's been there forever and I'm really comfortable with it. And I can't remember, there was quite a lot of discussion over try.
Oh, I actually did get
and
it. It didn't
things
get
like
taken
that.
out.
Oh, it did?
This is RC1. So
but
it
it's
must be
not there
there.
anymore.
No,
Yeah,
no, I
there's
think-
been some
I think it
discussion
is
about
there.
whether it's really needed.
Well,
and
This was
Lots
based
of
off of
stuff like
Twitter's,
that.
and it does not follow all the monadic laws. So
yes.
it's got a little issue there, but it's the debate was between the people who didn't like that and people who felt it was practical. But
Yeah.
despite that.
I say this is getting into a more general piece of advice, which is you don't develop, at least most people don't develop in a vacuum. You've got a lot more choice in Scala. There's a lot more taste involved in Scala. You should communicate with your team and decide what you think your best practices are. What you decide you're going to adopt as the way that you're going to communicate with your code. It's not like Java where you've been basically placed in a straitjacket and then beaten repeatedly with the stick of justice until you can only do it the one way. You have lots of options. using those options responsibly
Actually,
is really up to you.
And what this talk, this part of our thing is just really about helping people kind of navigate that ocean of options.
If you want a starting point, Daniel Spiewak produced a very nice readability document that, while you don't have to adopt it wholesale, if you've got no other place to start, it's a great place to start from. And it explains, you know, everything from readability and formatting the code to good things to use and bad things to use and stuff like that. So that's a good place to start.
So you had a couple more, I think, and if there's...
Yep.
Yeah,
what was the second question?
The thing is actually a pointer. You mentioned the collections with all the great methods in there. There's a search engine where you can search for type signature. So when you say, I'm looking for something that converts an A to a list of A, you can put that in there and it shows you a list of all the methods.
Oh my God! What search engine is that? Okay,
so
I'll get the answer, then we'll repeat the question.
Yeah.
But
ScalaX.org.
wow, ScalaX.org.
So ScalaX.org apparently gives you a lot of information about type conversions and
EX.
ScalaX. Oh, ScalaX.
No,
ScalaX. ScalaX.org. Oh, that's like Scalax.
This is amazing. So I want to go from
Hoogle for Haskell.
Scala
wow, there's a Hoogle for Haskell as well? That's
let's see where
excellent.
we should go. Something, I don't know, int to double or something. That this would be terrible.
Yeah, no,
hopefully
let's not
we won't
do that.
find something from, I don't know, what's an example? String to...
Well, what about any ASOG? Any arrow
Oh, yeah,
ASOG?
okay.
Any to arrow ASOG. How about that one?
Any to arrow ASOC. Arrow? It's actually T to arrow ASOC.
Oh, is it?
Yeah, it's T to arrow ASOC of T.
Hey, there we go. I found it. Wow, that's cool. Okay, so I think that answers a question that somebody else had earlier on, which is...
cool. Who did this?
Who did that?
Anyway,
Okay.
anyway, thank you very much for pointing that out. So he just had this comment. It wasn't a question. Is that if you are looking for...
An
that's just
implicit
awesome.
that does that kind of thing. Wow, that's really cool.
I'm glad I came to this today.
Yeah?
Third question. You get to do another one.
Is there check
there's something
style for
called
Scala?
Scala style. Is there something called like
Yeah,
check style for
there's
Scala?
a Scala style. I don't use that.
No.
IntelliJ is starting to get some helpful hints, and you can also define your own. It's immature at best right now. There's not really anything. Is there a project that you could support? Oh, to get involved with? I don't know, actually. I haven't looked for one, so...
the one I know of is Scala style. That's what it's trying to do.
Yeah.
But I've never looked at it. Because, of course, we think we have good style already.
Well, I have perfect style. And everybody else has to
one
bend
more
themselves
question
to
and we're
my
gonna move
style,
on.
so there is no problem.
But not from him. Anybody else? I thought I saw one more hand somewhere. Otherwise, we can move on.
We should move on.
Okay, let's
yeah,
move
let's
on.
do it.
Oh,
I'll
this is me,
fly.
I guess.
Yep.
So I'm not going to make it through all of this. So let's see. What I'll do is talk about the important things. So how many people here are like in what you do internally at a company? Well, how many people use Scala at your job? Let me ask you that. Oh,
not
too
many. Okay.
Oh, okay.
Oh.
Well,
Hey, if any of you want to, let us know. we can usually, I don't know, we're always on the lookout for people.
So what this second part is really about is if you're defining a library or a framework, and these are sort of best practices in that area, whereas the first part was more coding. And one thing that's, I think, true of Scala more so maybe than Java is there's this two different kinds of users. There's people who write libraries and people who consume them. And for people who consume them, things can be pretty simple, actually, unless they hit a type error that's confusing. But for when you're designing a library, then you've got all these power tools, that some of which are kind of complicated and deep and whatnot, that you can use to make it simple for everybody else. And so that's what libraries and DSLs in Scala, the thing is that Scala does give you a lot of power to make the code look however you want it to look. And so you can use that to make it look very cryptic, or you can use it to make it look clear. And in my opinion, a good way to use Scala is to make it clear.
You can use it for good, or you can use it for evil.
Yeah, and yeah.
Don't be seduced by the dark side.
So, library versus DSL, I never actually liked calling things DSLs that weren't actually really languages with a grammar and a compiler. But everybody does it, so I do it. And the difference is, in my way of using the words, is a library, it's more obvious that I'm calling that this is a method call and what I'm doing. And in DSL, it's you back up and it's a higher level of abstraction, and really it's more, when I look at the code, I know what you mean, hopefully, but I don't necessarily know what's going on behind the scenes. So there's more magic around the code in a DSL. So like from Scala test, there's an assert, which is more like a library call. I can see I'm calling a method and I'm passing in a Boolean expression. And a match expression, the result should not equal 7, is a little more magical, but it says, it's sort of at a higher level, it's the person who wrote the code is speaking directly to you, who's reading the code, what they have in their head. And how it works behind the scenes is a little less obvious. I'm actually going to talk a little bit about this Thursday when I have a simplicity, talk about simplicity. But
you should plug that talk about, go and see Bill's talk on simplicity in library design. It will be very good.
So I will talk about operators there and show more detail about how I think you should use them. But what I think the way you should think about operators, symbolic operators, is that if your users are already experts in that operator, then it's better to use the operator.
Yeah.
And if they're not already experts, then it's often not, it's probably better to use some kind of word.
Description.
Yeah, I mean, it's real simple. That's basically it. So it's not wrong to use them, but I just find that in a lot of the libraries out there, people use them too much.
I've never found that one in SBT particularly helpful, for example.
Yeah.
That doesn't mean a lot to me.
For example. Okay. That's enough said about that. Implicits you should use with restraint. In general, number 4, allow them to invite them in by putting them in making them import them or extend something that has them, so you inherit them. Except when it's always going to be wanted, then you would stick them in the companion objects so that they're just there.
Yeah, if you remember what implicits are for, it's a good thing. Implicits are to get rid of anything that's so ubiquitous that it's annoying. If something is used to the point where you're like, oh, I have to do this again, that's a good candidate for an implicit. They shouldn't just be thrown in willy-nilly if there's another way of doing it.
Use them with restraint. That's the main thing.
Yeah.
And by name parameter, I think
we've covered that in the idiomatic.
I don't know if we really talked about it, but a by name looks the same as a by value parameter, where you just put some code there in an expression, but what happens is that Scala will actually wrap that in a function and pass it up. And so it has this overhead for the compiler. It's got to create a function. Anytime you got to create a function, the compiler actually has to use up some memory. So if you have too many of these, it actually takes longer to compile, which is, I mean, that's premature optimization. But that's one thing to keep in mind. It's also just more, it can be more confusing in Scala because Scala has side effects. You can actually put side effects in things. And if you have a side effect in this thing that's being passed up, then actually it does matter to understand your program when that thing calls it and how often it calls it. If it was just a pure functional language, it would be no more complicated to use a by value parameter or by name parameter. But I think because of that, the default should be by value and use a by name when you have a special reason to.
I'm just giving a quick println.
So def do summit up there, f:\rocket unit. F is a by name parameter, and it will be
every time you refer to that name, it executes the function again.
Yeah, it doesn't call it. It doesn't execute evaluate the expression before being passed in. So,
right.
Okay.
Okay.
So that's enough said about that. And this one too, I think there is debate in this Scala community about how functional, Gesundheit, how functional to make things.
I think we've covered this.
Some people seem allergic to imperative code.
Yeah.
And there are people who really like Haskell and they want to program like that in Scala. And Haskell's a great language, but I think, in my opinion, it doesn't fit as well on the JVM. So what I think the really sweet spot of Scala is mostly functional, like turn the knob 85% or most of your code is functional. But then there comes a point where you keep turning it and it starts making things less usable. So that's where you would switch to an imperative style. So when you have that justification. So that, to me, that's, again, my opinion, and it's not everybody's opinion.
Yeah, it's a pretty good opinion.
But, you know, it's
I agree
lean
with that
towards
opinion,
functional,
therefore
it's the
it's a good one.
default, but don't be afraid to use the imperative when it makes sense. And, of course, you have to use your own taste to decide when that makes sense. But, yeah. Okay, enough about that one. Oh, yeah, so this is a little bit of stuff that's coming in my thing on Thursday. But, for example, I had to decide when I did this thing called Fun Suite whether or not to have a registration side effect. The way this works is when you instantiate a Fun Suite, or a class that extends it, it invokes test, and that registers a block of code as a test with a certain name.
That means
that's a side effect.
Yeah, it has to have
right?
mutable state to cope with that.
Yeah, so I like to not do that by default, right? So I considered how to do it without a side effect, and I think if you go to the next slide, this shows an example. And what you can do is you can say val test equals, and then have some operator or some kind of compositor that connects objects of maybe class test with a big T, and that's more functional, and you don't have the side effect. That's how you do it. And when you compare these side by side, I felt that if you go back to the previous one, it's just cleaner, right? That's actually what is in people's head, test, test, test. And so by stepping back and making that one thing, that one side effect, it actually cleaned out some boilerplate. That's the kind of thing. Yeah.
I had a similar decision to make with Subcut when I wrote that. I wanted a convenient DSL that was clean to do the bindings. So Subcut has mutable state within it. But I also used a couple of the other tricks that we've shown you here so that mutable state never escapes the construction phase of a binding module. As soon as you come out of the constructor, it's immutable after that point. So people can reason about the code without worrying that it's going to change. Okay? So convenient DSL, still immutable state when people try and use it.
Yeah, that's actually the same with this.
Yeah.
So when you construct a Fun Suite, if you go back to the previous one, it has a side effect during the construction. As soon as somebody calls a run, it's kind of frozen and immutable after that point. So, okay, let's move on. So it's just an example. Since we didn't talk about abstract members, I'm not sure how valuable this will be, but one thing about Scala is it's got a lot of stuff in it. And Martin Diersky, who designed the language, wanted to make it orthogonal. That's the word he used. So that there aren't special rules that this thing only works here and it doesn't work over there. So in Java, for example, it's not that way. Types can be parameters but not members. Methods can be abstracted over but not parameters until Java 8 or whatever it is that gets lambdas. And then you can pass a value as a parameter, but you can't have abstract fields. So in Java. In Scala, you can have both for all of those things. So for example, types can be parameters. You can also have abstract type members. You can say type T. And methods can be abstract members, like in Java, but you can also have kind of pass in a method kind of thing as a parameter by a higher order function, passing in a function object. And you can actually have, values can obviously be parameters, but you can have abstract fields too, abstract vowels. Yeah. So how do you decide which ones to use? Especially between type parameters and abstract types. Do we have a list on the next slide? Yeah. I think that'd be better, because otherwise I'd have to try to remember. So this actually took me a long time to kind of come to figure out how I use them. So some of the differences, you can have variants in type parameters, but not type members. So type members are non-variant. So if you want to have like a list of T and then subclass, like a list of string is a subclass of list of any, you need to use a type parameter. Type members can have a name, whereas type parameters don't. Well, I mean, they have a name, but when you use them, you have to just put things in order. So it's kind of like the difference between using named parameters and just calling a method that way. If I got a bunch of parameters to pass to a method, it's kind of helpful to say this equals that, this equals that, this equals that.
Yeah.
If I just call them in order, it can be a little bit confusing. So if you have a lot of type parameters, it's the same thing. It can be confusing which one's which. Because type members have names, it can be more clear. So I think they scale better for when you have lots of types. Type parameters have to be placed at the top. Type members can be placed anywhere in the body. So it can actually make the code a little cleaner. So yeah, there it is again. Because they're named, type members scale better if you need to specify a lot of types, I think. You can actually define type members and type parameters with mix-ins too, so that's actually not true.
I thought of one more on this list as well, by the way.
Okay, let's add it at the end. So the very last one on this list, before he has one, is that you can use the pound sign or dot notation to get out a type member, but you can't do that with a type parameter.
And the last one, unless I'm mistaken, but I'm pretty sure I'm not, you couldn't use an implicit context with a type parameter.
Yeah.
With a type
member.
You can only use it with a type parameter. So if you're using an implicit context, you need to make it a type parameter, not a type member. Okay.
Yeah, we should add that. Okay. I'm not going to say that. I don't believe that one anymore.
See, they change over time. Prefer case classes and pattern matching. Actually, we've talked about this as well, I think. I think we've covered this one, haven't we?
Yeah, this one is only, the idiomatic way to do the observer pattern in Java is not the idiomatic way to do the observer in Scala. In Java, you did this kind of thing where you made a mouse listener with mouse clicked, mouse entered, mouse exited, mouse pressed, and so on. And you just have this one mouse event that has everything. And go to the next one, yeah. So in Java, you'd make a mouse listener with an apply method, and you'd have mouse event be a case class hierarchy. And the reason is because when people receive events, they want to be able to pattern match.
Yeah.
That's all. So I think that's probably an obvious one.
Yeah. Okay. Default
Well,
parameters to
yeah, so I think the default...
You know, I'm not sure I recommend this anymore. It's an option. I don't think I'd prefer it at this point. I'd consider it every time.
What?
Using default parameters rather than ad hoc overloading. I find ad hoc overloading I use more and more because I need more flexibility than default named parameters.
Yeah, so the thing is, it is more flexible, ad hoc overloading. And what that means is I make multiple constructors that have different type signatures or different numbers of parameters. So if like I have a point takes 2 ints, I could have an auxiliary constructor that just takes 1 int, and I could have an auxiliary constructor that just takes 0 ints. It's a little less, it's nicer in that kind of a situation to use default parameters.
Yeah.
And, but there are a lot of situations where default parameters don't give you what you need.
One of the things you should know is there's a rule you can't mix them. You either have ad hoc or you have default and named. I don't think you can mix them.
Yeah, you can't mix them was what I always thought was the rule, but recently
it might have changed in 2.10.
I found a way to mix them. I can't remember how. But okay, let's go on one more and then we'll take questions.
Yeah, actually, yes, I want to say something quick before the questions. Do you want to do this one first?
No, go ahead.
No,
I thought you wanted to say about this.
Yeah,
so I just said that.
Finish this.
Ad hoc overloading, if you want to pass either 2 strings or 2 functions, then you have to use overloading. So there are some things you can't do with named default parameters.
Are we finished?
Yeah.
Are we finished it? Okay.
Yeah.
2 things I want to say really quick. The first is Scala. Oh, why is this not working? Why is your...
It's the presentation. You want to get out of it and just hit the little red circle there and go back to the slide.
Okay. So
this will...
Oh,
you're trying to go to... you're trying to go to... scalacoins.org. Yes. No, with an S. If you're coming to the thing this afternoon, and if you're planning on doing a hands-on labs with this afternoon, you can
yeah, just search for it. There's a Scala Cohen. Yeah, if you search for Scala Cohens, it's the first one in there.
scalacoins.org. That's what you typed. I don't know why I didn't like.
And if you go to installation and getting started, things will flow a lot more smoothly if you can have done this stuff before you come to the hands-on lab this afternoon. Otherwise, you're going to spend all the time setting it up and no time actually doing the Cohens, which is no fun. Secondly, very personal, cheeky request. Roman Guy and Chet Haas, very good friends of ours, are in a room opposite. I'd really like to beat them in the voting up, voting down. So please remember to vote on your way out. Because if they win, I'm never going to hear the last of it. So anyway, that was the other thing I wanted to say. We got 9 minutes left,
I want to just
so
take
let's
some questions,
do
have
some
conversation
questions
here.
and anything people want to ask.
Somebody in the way in the back. Anybody in the back? We'll start up there. You guys wanted to be invisible, but...
We're watching you.
Okay, anybody down here?
Yes.
Yes.
How's IDE support for?
Oh, how is IDE support for Scala development? Way better than it used to be. Still room for improvement, I think, is probably the report card that I'd give it at the moment. I use IntelliJ IDEA. It's got pretty good. It's still, there's a couple of quirks that you need to know about, particularly with putting breakpoints down and debugging. Sometimes things don't work quite as you'd expect there, but you learn to live with it. And I've been using it very effectively. The refactoring support is really good now. Syntax coloring and code completion is really good now. Sometimes it complains about errors that aren't real when you turn on the enhanced type checking in IDEA, but that's not too bad normally. For the most part, pretty good. Eclipse is coming on in leaps and bounds as well now because TypeSafe has taken that on as the new supported thing. So it's improving massively. I'd say it's very easy to be effective in a Scala IDE now. Are they as polished as Java? No, not even close yet. But they are very effective, and I would rather use an IDE than not.
Yeah, they're usable. I also prefer IntelliJ, but for about 6 weeks this year, I used Eclipse just to see, and when we were doing the plugin for Eclipse for Scala test, and it was perfectly usable. It's just was still Eclipse, but, which some people prefer it. I like it. I like the other one. Personal preference. Yes, Peter.
Oh, build tool SBT. Oh, don't get me started on SBT. So people in the Scala world use SBT. The reason is it's really, really fast to compile. And occasionally I find individuals who really, really like the model. I don't like the model, I'm sorry to say, but I find that I want a build tool that just builds and gets out of my way. I really don't care how clever the implementation is of it. It just needs to build the thing. And I find it hard to remember the... Apparently I said var again. I find it hard to...
You know what? It's either you said it before or right after, because every time it goes goes off, you say, oh, did I say var?
I said var,
which
yeah.
you did say.
It's time traveling. I find that the operators are confusing. I can't remember them. I find there's a number of things that are sort of just annoying about it, and it takes too long to do stuff. That said, everybody still uses it because it's really, really fast at building Scala stuff. So it can't be doing everything wrong. Otherwise,
no. And the other thing, well, one thing that's nice about it is the way it improves compile time.
Yes.
People love that about it, and that is also available in a separate library now called Zinc.
Yeah.
So hopefully that's coming to other build tools.
Gradle has Zinc support, I think now. Yeah. So there's other options out there, but I think right now everybody uses SBT because build time is so important.
And there's another feature that if it will ever get to here, God, it takes forever. That I want to show that I think people really like about it is test colon console, or even just console. You say console, test colon console gives you a Scala shell with everything in your project in like the test class path available, so you can try stuff out.
You can then
just like that, and that's really nice. And if you say I'll exit, but if you say tilde test colon console, tilde means
or just tilde
that
test.
it'll recompile.
Yeah.
Not tilde test. I don't want to run them. I just want to run the console again.
See, another thing
Basically, tilde anything will rerun it each time you change something automatically. So that's really nice too.
Another trick I do is I use tilde test, particularly with something like the Scala koans. This is good. You do tilde test every time you save a file. It recompiles what it needs to and runs the tests again immediately. So you don't have to type the command. It just keeps telling you this test is still broken, and you just keep editing stuff until it all turns green, and then you're done.
So anyway, what people don't tend to like about it is the syntax. It's hard to basically. It's really. I think people find it hard to understand the build file.
And even when you do understand it, it still makes it hard to change stuff that you want to change. If you do it its way, it's fine, but you know, some of the decisions that have been made, build tools, you know, things that you need to do in builds a lot are, for example, build a jar and then deploy it to a website. And trying to explain to it not to try and do these things in parallel is sometimes very hard. I mean, I appreciate the fact that it's trying to do everything in parallel, but you can't put a jar out onto a site until it's actually been built. So, you know, that's a tough one sometimes. It's too hard to do stuff like that.
So any other questions we got? Oh, 4 minutes left. Yes.
About the constructors, they're always public.
Oh, no, that's a great question. Are constructors always public? No. You can make a constructor private by saying class, person, private, and then give it the constructor, like that, the constructor parameters.
Those secondary can then be public.
The secondary can, yeah, so the secondary can be public then. Alternatively, you may not have a public constructor at all, but you could put factory methods into your companion object, and that's then the only way for somebody else to create.
So I can say
that is to go through
new
your factory
person
methods.
like that, but I can't say new person.
Constructors support for super types.
How do you change the, sorry. Oh,
Chain.
how do you chain the constructors for super types? So the only constructor that can call super is the primary constructor. Up until that point, when you create the auxiliary constructors, you call this. You call another constructor in this thing, and eventually that has to reach one of those has to reach the primary constructor in order to call the super constructor.
So here's an example: class person age. I can say class subperson.
Oops.
Extends person of 10 or something. I shouldn't say a person, but little person.
Yeah.
Okay, 3 minutes. Anybody have a 3-minute question?
I've got one. What's for lunch?
I don't know. Probably something
Sandwiches?
exciting. Yeah. Well.
Or a pasta salad.
Anything else?
All right.
All right. Well, that's good then.
Thank you very
Thanks for
much.
coming. Remember to vote, and
Go forth and Scala
hopefully we'll
rise.
see some of you folks this afternoon at the Scala.
Live long and prosper.